Okay, so today's date, 1/23/19. Okay, the objective today, we want to graph absolute value graphs. Okay, y equals, and this is my symbol for absolute value, okay? That's my symbol, okay? That's my absolute value symbol, okay? And we always know that in this symbol, all outputs are positive. Okay, you got an input and an output, right? Input goes in, output is what pops out, okay? That's easy. Input goes in, output pops out, okay? So let's go ahead and do a little t-table on this, okay? So we want to let x be 0, 1, 2, 3, then -1, -2, -3. So, okay, my t-table, I go 0, 1, 2, 3, and then I'll go -1, -2, and -3, okay? So whatever goes in as an input pops out as an output positive, right? So that's easy. So if I were to take 0, put 0 in for it, okay? So I do y equals the absolute value of 0. Well, the absolute value of 0 is just 0, would you agree? So I'd have a corresponding y value of 0. If I put in 1, right, the absolute value of 1 is just 1. If I put in 2, the absolute value of 2 is 2. This is pretty easy, you guys agree? If I put in 3, right, the absolute value of 3 is 3. Okay, now let's do the negatives. It has to come out positive, right? It can go in negative. It can go in negative. So I put in a -1, but it pops out a positive 1. It goes in negative, can, but it pops out a positive 2. It goes in as an input as -3, and it pops out as an output of 3, okay? Now, with the t-table, what we've done is created points, okay? These are just points on the graph. This is the coordinate 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, and -3, 3. So these are points on a graph. That's what we did. Put in an x, we got a y, xy value, right? So let's graph these. Let's see what it looks like, okay? So, let's see. I'm looking for a pen that I want. This will work. So, if I plug in 0, 0, right? 1, 1, 2, 2, 3, 3. I'm going to have a coordinate at -1, positive 1. I have a coordinate at -2, positive 2, -3, positive 3, okay? Now, there's a whole lot of points that I didn't use, but they're still part of the graph. Again, I'll say it again. There's a whole lot of numbers I didn't use, but they're still part of the graph. I mean, I could plug in 1.5. I could plug in 0.6. I could plug in pi. I could plug in any number, but that would be a pain, so that's why I just draw the line, okay? So by drawing the line, I'm including all of the numbers in between and far and beyond, and put an arrow there because I'm going to include the numbers like 100, the arrow, I'm going to include 100, include 1,000, but you know, the arrow tells us that all of those numbers are included. And on the back side, on the negative side, it looks like this, okay? Okay. Now this is called the parent function, the basic. The basic graph is called the parent function. So plain old y equals x is called the parent function. Okay? I know, somebody last period said, well, Mr. Stevens, why do they call it parent function? I go, well, could have called it the standard graph. Could have called it the basic graph, right? They just choose to call it the parent function. It's the basic graph. Now we're going to move it. We're going to do some things with it. We're going to move it. We're going to stretch it. We're going to make it bigger, shorter. But this shape will move. This shape will modify, okay? So, in example 2, right? We could do this whole t-table thing again, but that would be, you could, but that would be a waste of my time, really. So what I'd rather do is just take the graph, take this parent function, and just slide it down 4. Does that make sense? Just bring it down 4. That's all we're going to do is take this function, bring it down 4. So the vertex, and this would be its vertex, right? It's the pointy spot. It's the lowest spot. That's the vertex. I'm going to bring the vertex down to -4. 1, 2, 3, 4. And I'll put the exact same shape, right? So I'm just going to take this graph, and slide it down 4, so it still is the 1, 1, 2, 2, 3, 3. It's still the exact same graph. I've just moved it down 4. All right? Easy. That's called a translation. When I move a graph, it's called a translation. So translation is to move a graph without changing its shape. Okay, so I didn't change the shape. We moved the graph. I did not change the shape. Okay? So translation, we just moved it down 4. That's all we did. Thumbs up so far? Okay. Any sideways? Okay, good. All right, turn the page. Now, domain. Oh boy, what is domain? Okay, so domain is all possible x values, okay? All possible x values, okay? Domain's important, especially in science. Domain's important, especially in science. Because in science, you do all sorts of experiments, right? You're doing an experiment, let's say in Stubbs' class. You got a stopwatch, you start the stopwatch, and you get time, right? Why is domain important? There's no negative time, right? And that's why we say, okay, wait a minute. If you say, well, t equals time, it would be negative, right? So domain is important. Now, range is just all possible y values. So the x represents like the x-axis. Here's how I always get kids to remember, okay? I always try to do silly little things, but so you don't remember, okay? Domain. I always say, don't mess with my domain, okay? Domain, don't mess with my domain, because this is my domain. It's how wide a graph is, which is the x value. Say it again. This is my domain. Don't mess with my domain. Don't trip over it. So how wide is the graph? I know you're laughing. You should laugh, because I want you to remember this, okay? How wide is my domain? This is my domain, right? Reach for your range. Does that make sense? Reach for your range. How tall is the graph? Because your y values are the ones that go up and down, okay? So don't mess with your domain. Those are your x values. And reach for your range, okay? So, first, let's graph this one, okay? So, example 3. So, I want to take the graph I just did, and I'm going to bring it down 4, but the difference is, on this one, I'm also going to make it twice as tall. It's like slope, okay? So, I know the graph, my parent function is the v, right? It's the basic v. That's my parent function, but we're going to take it down -4. So we're going to slide it down to -4. 1, 2, 3, 4. And instead of going up 1 over 1, up 1 over 1, think of this as a slope of 2 over 1. So it's going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay. And we also know that on the other side, its negative values have to also go up. So it's still the v, but it's the v that's twice as tall. Up 2 over 1, okay? Okay. So what do we have? We brought it down 4. And we made it twice as tall. Changed the slope, didn't it? Okay? Easy. So now, domain. Let me ask you a really easy question. As this graph keeps going up, it's always moving over. You guys agree with that? So it's always going over, always going over. So what's going to happen is it's forever wide. It's always going over. It's forever wide. So what are all the x values? It's all of them, right? So we're going to say the domain is x equals all real numbers. So any x number you can think of is going to be on that graph. 5, 100, pi even, right? 17, -10, any possible x value is on that graph. Even though it's going up, it's always moving over. But the range is different. There's nothing down here. The graph does not exist down here as far as height. Reach for your range, right? There's no graph down here at all, so the range just starts at -4 and goes up, right? The range is your y, so we're going to say y is greater than or equal to -4. That's the range. Okay? Start at -4 and go up. Thumbs up? Sideways? Where are we at? Good. Okay, no thumbs down? Okay, slide it up. Now, this one's a little bit tricky. So, before I do this one, I want you guys to think and listen very carefully. Look right here where my pencil is. What x value would make this 0? What x value would make this 0? What x value here would make this 0? -3. Perfect, okay? So when x equals -3, it's going to be at its lowest spot, right? So the vertex of this one has to be at -3, -4, because -3 would make the lowest spot. It's zeroed out, right? So whenever you do anything on the inside, I do all sorts of stupid things, again, like this, okay? From your perspective, okay, which way am I moving? Which way am I moving? Yeah, but I'm really moving right. It's the opposite. It's the opposite of the inside. And you know why it's the opposite? Because what x value here is going to make that 0? -3. So it's the opposite of that, okay? So let's go to a vertex of -3, -4. 1, 2, 3, 4. So it's the opposite of the inside. I'm going to make a little note. So it's going to be a horizontal shift, but it's going to be the opposite way. So instead of going +3, I actually went back 3, didn't I? Right? Instead of going +3, I actually went back 3 because I'm here, went back 3, down 4. And now it's going to be twice as tall. Remember that? So I'm going to do twice as tall. So I'm still going to do for my vertex, we're going to go up 1, over 2, up 1 over 2, up 1 over 2, up 1 over 2, 2, 2, 2, 2, and I'm going to graph it in. Oh, I missed one, didn't I? Nope, I didn't. Just put my ruler in the wrong spot. There we go. And there you go, okay? Domain. How wide is this graph? How wide? How wide is this graph? Remember, it keeps going and it keeps going and it keeps going. It's forever wide. You guys agree? Yeah. So it's forever wide. It's always moving over, isn't it? So x equals all real numbers. Yes. X equals all real numbers. There's a symbol for that. If you want to use a symbol, it's a capital cursive R, and that way you don't have to write, if you don't like to write all real numbers, that's the symbol for all real numbers, okay? Cursive capital R, okay? Range. -4, perfect. We started at height of -4, right? The lowest value, the lowest y value is -4, and then it goes up. Thumbs up? Okay, good. Range of domain's getting easier, right? Okay. All right, what do you think? Example 5. Can you graph it?
Yeah.
Okay, give it a try. You guys try and graph it, okay? Okay, vertex, I like to start with the vertex, is at +2, 5, because it's the opposite. +2 is zeroed out, right? Okay, so that's where I'd start. Nice job. Okay, everybody okay with positive 2, 5. There's my vertex. Isaac drew his. Nice job, Isaac. Like that. Why is Isaac right? Whoa, how? Yeah, it's like a slope of up 1 over 2. Totally right. So it's like a slope of up 1 over 2. So Isaac just started from my vertex. He went up 1 over 2, up 1 over 2. So it's half as wide. It's half as tall, or twice as wide, right? And there you go. Okay, domain. Should be easy. Domain by now. This is real. This all real numbers agree. Everybody agree it's going forever both directions. So x equals all real numbers. There's my symbol for all real numbers. In my range, y is or equal to 5. Okay, nice job. All right.